File upload is easy until files get large, unsafe, slow, or expensive. When I think about file uploads, I start with the real job: profile image uploads, customer document ingestion, and large media uploads with different size and safety requirements. Before we pick components, be clear about the workload. This design has to handle direct upload versus server upload, signed URLs, object storage, metadata, virus scanning, file validation, chunking, permissions, and cleanup jobs, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually the application server, receives every file, holds the connection open, and stores metadata only after the upload finishes. I still start simple on purpose. The smallest version that can work here is the application server, receives every file, holds the connection open, and stores metadata only after the upload finishes. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next. Large uploads saturate app servers and make latency or memory spikes somebody else's problem later. The first production pressure usually shows up here. Large uploads saturate app servers and make latency or memory spikes somebody else's problem later. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic, the pain looks like unsafe content, incomplete uploads, and permission mistakes introduce security and correctness risk. And then comes the part junior diagrams almost always skip. Storage costs and orphaned files grow quietly unless lifecycle and cleanup jobs are part of the design. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is signed URLs to object storage, async processing workers, metadata tracking, validation, scanning, chunked uploads, and cleanup for abandoned objects. This is what you gain from the stronger design. Direct-to-storage upload paths reduce server pressure and make large file handling much more practical. Those gains are why the extra complexity is sometimes worth it, but there is always a bill to pay. The cost of the stronger design is you must manage async processing, signed URL lifecycle, validation outcomes, and metadata consistency explicitly. That trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask what happens if the upload is interrupted halfway, the scan fails, or a user keeps retrying the same multi-gigabyte asset. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Trace a client request into signed upload, storage landing, scan and processing workers, metadata persistence, and download or CDN delivery. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers understand how to safely and efficiently handle file uploads at scale. Good system design is a judgment loop, not a memorized answer key.